Hi, this is Dr. April Meganson, and today we're going to be talking about how we can look at our data that we've collected as school counselors and break it down and look at it like a boss. So, what we're going to do first is we're going to look at, so we have 7 students who have been a part of maybe some group. We have their pre-test data, their post-test data, what their attendance was like before they began the group, what it's like at the end of the group, what their grades, their average grades were before group, and then what their average grades were after. So what we're going to do first is we're going to find the mean or the average of each of these scores to see if there's a difference. So right now we're seeing if there's any growth. So what we're going to do is there's this wonderful sum sign. You're going to click it and it says average right here. So we're going to let the computer do the work for us. And here it even highlights exactly what I need. I'm going to press enter and go to the next. Now it's not guessing what I really need, so I'm just going to click here and click on those scores. And I'm just going to keep doing that, highlighting the scores that I want the computer to average. And here we go. And as you can see, there is some growth here. So the average student's pre-test was 18.43 and their post-test was 20.86. So the average student grew 2.46 points within this pretest. Their attendance got better, went from 80% attendance to 86% attendance, and their grades got better from a 73% to 84% on average. Now, right now, this looks great. However, we can take this a step further by really looking at, is this statistically significant, and is there a good effect size? Meaning, is the difference meaningful as well? So the first thing that we're going to do is we're going to find statistical significance. Okay, and the way that we do that is we're going to be doing a t-test. So we're going to come back over here and we're going to click more functions. Now because I just used it, it's going to be here, but you could just type in t-test and it will come up. So we're going to do t-test and we're going to insert function. So what it's going to ask us is a number of questions. The first one is array 1, and really that just means this is the pre-test data, and we are comparing it to the post-test data. We're using a two-tailed approach, meaning that given our intervention, students actually, the scores might have gone down or up, we're not quite sure. And then because this is a paired t-test, meaning that student A's score is matched both pre and post, we're going to type in a number 1. We're going to click done, and it's going to deliver us our statistical significance, our p-value. So I'm going to write in here p-value. This is a good number for us because what this does is it kind of shares with us that it is under the 0.05. So anything 0.05 or below means that there is statistical significance. Again, that doesn't mean there's a great big difference. What it means is that the difference is not a fluke. Okay, so we're going to do t-test, our pre-test as array 1, then we click into array 2, post-test, again it's always, we're going to want to put two-tail, and it's a paired t-test. Now if we look at this, 0.17, it's over the 0.05, which means that the attendance is not statistically significant. There could be a fluke in this. So we're not kind of finding the data that we want, but we're going to keep on going. So then the next thing that we're going to do is we're going to do the t-test for the grades. So we're going to insert array 1 as the pre-grades. array 2 is the post grades. This is two-tailed, and it's 1. And this is 0.00, which if we made it bigger, we'd see that it was 0.004. This is great. So really statistically significant, our p-value shows us that the pre and post test and the grades were not a fluke. So then that's going to be kind of what we're going to focus on. The next thing that we're going to want to find is Cohens D. But in order to find Cohens D, which is our effect size, is this difference meaningful? So we're going to do standard deviation. Click on where we want it to go. Then again, we're going to click more functions. Standard deviation, we're going to insert it. And we're just again going to pick our scores. And it's going to give us the standard deviation. So we're going to do this for all of our different scores. And at this point, we're going to skip attendance because we didn't find that this particular intervention was statistically significant for that. So it's a bummer, but we're going to just keep moving forward with what we do have. So here we have, and because I don't like those long numbers, I'm going to bring it down. So that looks good. So next we're going to do Cohens D. So next we're going to do Cohens D, which is effect size. So I'll put effect size here. Now, there's a way to do it. You have to do all these mathematical formulas, but what is really kind of cool is that there is a website for it. So I'm going to just click on the web, and I'm not getting a new phone, and I'm going to look up effect size calculator. I'm going to go ahead and use this one. So this kind of talks to us mathematically about what all these numbers mean, but what I like about this one is that it has, you just type in the information and then it tells you. So we're going to look at the mean. So we've already calculated that for group 1, which would be our pretest. Our standard deviation is 1.90 and our sample size is 7. Our mean for the post-test is 20.86. The standard deviation is 3.29, and again we have 7. So it's going to calculate it. It's going to do all the math for us. And it's going to come up with 0.90, which is actually a really big number. So typically when we're looking at effect sizes, what we're looking for is anything that's 0.2 is considered a small effect size, 0.5 is medium, and 0.8 is large. So we have 0.9, which is very large. So let's do this again. So let's use our calculator again for, again, we're skipping attendance, and we're going to calculate it for our grades. So we're going to start with 0.73, and our standard deviation is 0.11, so then 0.84, 0.09, also 7, we're going to calculate. And here we come up with a number larger than 1. So now we've found the effect size and the statistical significance fairly easily using Excel.